Okay, so now we move on to our next topic. This is AP Topic 10.3, called the nth term test. So the question is, what if we don't have a geometric series or p-series? So what do we do then? Because all we've learned so far is that we can tell if a geometric series converges or diverges, and we can tell if a p-series converges or diverges. But there are lots of other series out there that aren't either one of these. So the question is, how do we tell? So this lesson begins a few lessons in a row where we're going to need a lot of other tests to tell if a series converges or diverges. Now, before we jump into the nth term test, let's kind of look at our roadmap here. So we've already had a lesson where we learned about the geometric and p-series. And if you identify your series as one of those two, we have very clear-cut, easy rules about if they converge or diverge. But after geometric and p-series, things get just a little bit more tricky. Now, there is a series that we'll see in a few lessons called an alternating series. And an alternating series is very special, and it's pretty easy to spot, but it has all kinds of other stuff that comes along with it. So we're not ready to jump into that. So later, once you get more series under your belt, you'll be able to recognize geometric p-series and alternating series. But then if it's none of those three, then we have to start down this fourth option. And this is where we're going to start working today. And the first thing we do on the fourth option is check what's called the nth term test. And the nth term test doesn't tell us a lot, but it does tell us if a series automatically diverges. And if we see that, then we know the series diverges and we stop. It doesn't tell us it converges. It'll either say it definitely diverges or we just don't know. And then you have to keep going on to other tests. That'll be in the future. So today we're going to learn about the nth term test. And I will say that some people like to start with the nth term test before they figure out if it's geometric p-series or alternating series. And you might have your own preferences as well as you learn more about these. Okay, so what does the nth term test for divergence tell us? Well, here we go, and I'm going to make a big deal out of this, probably more than once. The nth term test only tells us if a series diverges. And what is that test? Well, we take the limit of the function part of the series, and if it doesn't equal 0, then the series diverges. Now, what does that mean? That means that if we take the limit of the function part and we get positive 1, it diverges. If we get positive 1,000, it diverges. If we get 1/2, it diverges. If we get negative 3, it diverges. Any number except for 0 tells us the series diverges. Now, there are some things you're going to wonder or you're going to encounter, so let's talk about a few important things here. While we are determining if the series converges or diverges, we're only testing the a sub n part. We don't actually do anything with the summation symbol, the n equals 1, the infinity, nothing like that. In fact, that leads to the next part. It doesn't even matter what number n starts on. So n can start anywhere. We are just looking at the function part of the series, not the whole summation symbol part. Now, I've said this a few times, and I've already made a big deal about it, that we only know that the series diverges. Read letter C here. The nth term test does not tell us a series converges. If the limit does equal 0, which is the only thing that doesn't diverge, then that only means we don't know. And that's really important. We cannot tell convergence with the nth term test. We can only say, well, it didn't automatically fail, so we need to do other tests. So it must equal 0 for the series to possibly converge. And then if the limit does equal 0, we'll need to apply other tests that we haven't learned yet, but we will. So, and then we'll know if it converges, or maybe it still does diverge. It just happened to not, the limit happened to equal 0. So I will say this again. Read number 1 up here again. Note that if the limit equals anything except for 0, then it diverges. And that's all we can do with the nth term test. Overall, it's not a hard test. Unfortunately, overall, it doesn't usually give us a lot of information. Now, here's where things could get a little tricky with this. You will have to use your limit skills to evaluate these limits. And number 4, you might actually have to evaluate limits of n factorial, which is something you probably haven't had to do before. In these cases, we want to imagine the weight that n factorial has. I mean, just think about what n factorial is. It's an infinite number of numbers multiplied together. I mean, n is already an infinity, but now we're going to multiply infinity times another infinity, essentially. You could say infinity minus 1, but that's not entirely accurately correct. Or entirely accurate. So, in any case, for example, the limit as n goes to infinity of n squared over n infinity, even though they're both based on infinities, the bottom one is infinitely heavier than the top one, because the top one is simply an infinity times an infinity, which is kind of hard to wrap your mind around, but the bottom one is an infinity times another infinity times another infinity, right? Infinity minus 1, infinity minus 2, so it keeps going to infinity on and times infinity. So the bottom is much heavier, we would say, and so the limit does approach 0, just like 1 over infinity approaches 0 as well. Okay, that's really everything you need to know for the nth term test. So let me run through a few examples for you. So let's say we had this series. We'll start with this first one, n squared over 2 times n plus 1 squared. And so we want to find out, what do we know with the nth term test? So we'll say, okay, so we want to find the limit as n approaches infinity of n squared over 2n plus 1 squared, which is the limit as n approaches infinity of n squared over 2, and then we have in parentheses n squared plus 2n plus 1. Okay, well, how do we take the limit of this? Essentially, we'd use L'Hopital's rule, or we can just use the coefficients in front of our highest powers, and so that'd be a 1 over 2, so the limit is 1/2. And according to the only rule here, right here in this box, if the limit does not equal 0, it diverges. So we got a limit of 1/2, which means that this series diverges. Okay. All right, let's move on to this next one. Okay, so now we have the summation from n equals 1 to infinity. Notice the last one started at n equals 0. It doesn't matter where n starts. Now we're at n equals 1. All right, the summation as n equals 1 to infinity of this function. So we're going to find the limit as n goes to infinity of this function, 3 plus 4 to the n over 2 minus 3 to the n. Now, essentially, as we are adding things to numbers raised to infinity, that front 3 and that front 2 are really negligible. They don't change our value taking 4 and negative 3 to infinity. So we're going to write the limit without that. And then actually we can recognize that since they're both to infinity, we can just say negative 4/3 to the nth power. Okay, now let's think about this one for a second. What's going to happen as we raise that to the nth power? Well, it's going to get bigger and bigger and bigger, and actually it's going to oscillate back and forth between positive and negative, but that top number being 4 over 3, it's going to keep multiplying to a bigger and bigger number. So it's essentially the limit of this is infinity. So the limit does not equal 0, so therefore this series diverges. I do want to point out, nope, never mind. I was thinking something else. Okay, that doesn't apply. All right, let's go to this third one here. Okay, so we have the series 1 over n to the third power, so we want to find the limit as n approaches infinity of 1 over n to the third power. And this should be a limit that you're familiar with, and you've done limits like this. Anything 1 over infinity to any power is going to approach 0, and so that's the answer to the limit. So what's that mean for the nth term test? Well, the nth term test just says right here, if the limit isn't 0, then it diverges. But we got 0. So what's most important is that you don't say it converges. It just say it is inconclusive. or you know what? That's actually pretty bad of me. I should not use the word pronoun it. So let me say the nth term test is inconclusive, and I'm going to run out of room to squeeze that in there. So there we go. What's that ultimately mean? Well, it just means that we're going to have to do another test on this series. That's not good enough to know, and so we're going to have to do something else with that. Okay. Now, what we actually should recognize is that 1 over n to the third is a p series, and so it does converge because p is greater than 1. And so that's what we learned in the last lesson. And so this is why I'm teaching you p series and geometric series first, because I'd rather you just recognize that's a p series and not fool with the nth term test, because it was inconclusive and you're going to have to figure out that it's a p series anyway to actually solve it out. All right, one more. So I mentioned that sometimes you have to evaluate limits when n has a factorial. So let's take a look at this. The limit as n goes to infinity of n to the fourth over 3n factorial. And this is simply an idea where you just want to realize n to the fourth, it means some kind of infinity times infinity times infinity times infinity, which is, impossible to wrap our minds around. But 3 times n factorial, well, that 3 is pretty negligible. But this is like an infinity times an infinity minus 1, which doesn't really exist, just another infinity. And factorial, it just keeps going, right? I mean, even if you took away 1, took away 2, took away 3, took away 4, it doesn't matter. We're going to have an infinite number of infinities multiplied together, which makes the bottom infinitely heavier. So 1 over something very, 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 very big approaches 0. And so again, we learned that we cannot say that this is convergent. We're going to have to do another test. Now, this particular series is not a p series. It's not a geometric series. So we'll need a test that we haven't learned yet. But all we can say is the nth term test is not conclusive. So that's all you can say there. And you would go on and start working through your other tests. Okay, so big picture. The nth term test is a fast test. It only tells us if a series diverges if the limit is anything except for 0. In the grand scheme of things, it's kind of the first test over here whenever we don't have a geometric series, a p series, or an alternating series, which we haven't learned yet. And so you're going to apply the nth term test. If it doesn't equal 0, you stop and say the series diverges. If the limit does equal 0, then you move on to some other tests that we'll be getting to shortly. All right, there you go. Thank you. Bye.